Hi, students. I wanted to put together a short video on solving what are called literal equations. This is something that pops up every once in a while on um, different tests, so like the GED test and the placement test. And it's also just a useful skill to have, maybe not so much in, or not as much in math classes, but in other situations where you might be using things like spreadsheets or doing other kinds of like real world work with formulas. So the problems for this, the examples that I'm going to go through come from the textbook section 9.7. And one of the things the textbook points out is that when you do work with with programs like Excel or Google Sheets, which are spreadsheet programs, those programs are able to do mathematical calculations. But in order to do that, you have to enter a formula. And those formulas are always entered in the form of some variable is equal to, and then you'll have some long mathematical expression. Well, sometimes you need to rearrange a formula to get it into the right format to enter into a spreadsheet or whatever other function you're doing. And so that's what we're going to look at today. We're going to go through three different examples here. Um, Oftentimes, what you're going to be rearranging will be formulas. So, like in this example here, we have the formula for perimeter of a triangle. So we know that perimeter is equal to, these would be the lengths of the three different sides added together. And what we're asked to do here is solve this formula for C. So let's say in this example, what I'd be doing is maybe I know the perimeter and I know two of the sides of the triangle and I want to find the third side. Or I want to enter that as a formula into, like a spreadsheet of some kind. So the way that I'm going to do this is, even though I don't have any numbers in this particular equation, I'm going to just recopy this for right now. What I want to do is think about the same steps of solving an equation that I would normally use, and I'm just going to work my way to getting C by itself. And I can get it by itself on the left-hand side, or I can get it by itself on the right-hand side. It doesn't really matter. But what I want to end up with is having C completely by itself. So I'm going to go ahead and highlight the C just so that I can remember that that's the thing that I'm trying to isolate, right? So what I want to think about, just like when I solve any other equation, is what else is happening on the side where the C is. And what's happening is that I'm adding A and B to that variable C. So I need to undo that. And what I'd like to do is move those over to the other side of the equation and get them away from the C. So I'm going to do that one thing at a time. I could do this in kind of all in one step, but just to kind of show this my thought process, I'm going to do it in two steps. And what I'm first going to do is I'm going to undo this A that's here, right? It's a positive A. So if I subtract A from both sides, I'll be able to cancel it out on the right and move it over to the left where the P is. And so what I'm going to show here is that A minus A is just 0. It cancels out. I'm going to bring down the equal sign in the middle. And I'm actually going to start on the right-hand side here. What I have left on the right-hand side here now, because I've canceled out the A's, is B plus C. And let's highlight that C again to show that that's what we're trying to get by itself. And then on the left-hand side, now normally I'd have two numbers here that I could subtract and I'd have just a single number as my answer, but I don't know what P is and I don't know what A is. And so what I'm going to write is just P minus A. Okay, this all might look kind of strange, but this is what we want to do. And so now in my next step, again, I want to go back to the right-hand side where the C is and look at what's being done to the C. And what's being done to the C is that I'm adding B to it. So I want to undo that. I'm going to do that by subtracting B from both sides. Again, I'm going to bring down my equal sign. And again, let's look at the right-hand side first. So b minus b is 0. That's going to cancel out, and I can literally just cross these off if I want to. And so now all that I have left over on the right-hand side is positive c, which I can just write as c. On the left-hand side over here, I've got p minus a, and then I'm subtracting b from that. And again, I don't know what any of these variables are, so I'm just going to write this as p minus a minus b. Okay. I do want to make sure I keep the order correct, because remember, order of operations and rules for subtraction say that we can't rearrange subtraction and get the same answer. We need to keep the order correct. So I started with P, I subtracted A from it, and then I subtracted B from that. So I want to keep them in that order. But now I've set out what I wanted to do, right? C is by itself. That's what I wanted. I wanted to find out what C was. And what I can see is that C is equal to P minus A minus B. So if I wanted to enter this as a formula into, say, a spreadsheet or some other program, I'd probably turn this around and put the C first and write it as P minus A minus B. And so I have successfully solved this for C. All right, let's take a look at another example. And this next example doesn't come from a formula. This is just an equation, but it's an equation that has an x and a y in it. And this time I want to solve it for y. And this is something that we actually do sometimes for graphing. And it's something that we do for being able to use a graphing calculator application. So this is something we might actually be looking at next week. So again, I'm going to recopy this formula. So I've got 7x plus y equals 11. What I want to do here is I want to get y by itself. So again, I'm going to highlight that y. Focus on that. And just like if I was solving any other equation, what I want to think about is, what am I doing to the y? What am I doing on the side of the equation where that y starts off? And what I'm doing is I'm adding 7x to it. So that tells me what I need to undo. I need to undo adding 7x. So I'm going to subtract 7x from both sides. Okay. 7x minus 7x is 0. So those are going to cancel out. I'm going to bring down that y. And then on the right-hand side, again, I don't know what x is equal to, right? So I can't do 11 minus 7 here, because that 7 is attached to an x. And these are not like terms. 11 and 7x cannot be added or subtracted. So what I'm going to do is I'm going to just write 11 minus 7x. Okay, now one thing about this problem is what you'll often see is there's kind of a convention in math that when you have a variable term and a constant term, or just a number term, on the same side of an expression or of an equation, usually you'll put the variable term first and then the constant term second. So I might actually turn this around and say y is equal to negative 7x, because that negative or minus sign needs to stay attached to the 7x that comes after it. And then the 11 is positive, so I'm going to put plus positive 11. Okay, and now I'm done, because again, I got the y by itself. I know what y is equal to. Y is equal to negative 7x plus 11. And now this is an equation that I could enter into a graphing calculator or a spreadsheet or some other program. Okay, we're going to do one more example, very much like this one, but with an additional step. So now we have 4x plus 7y equals 9. So 4x plus 7y equals 9. And again, what I eventually want to get by itself is the y. So I'm going to think about, again, what am I doing to that y on the left-hand side of the equation? Well, I'm multiplying it by 7, and I'm adding 4x to that. And so I've got two things I need to undo here. I need to undo the adding 4x, and I need to undo dividing by 7. So I'm going to do those. Remember, we're kind of working backwards through order of operation. So I'm going to undo the thing I'm adding first. So I'm going to subtract 4x from both sides. So 4x minus 4x is just 0. What that's going to leave me with over here is positive 7y. And again, on the right-hand side, these are not like terms. 9 and 4x are not like terms and cannot be subtracted. So I'm just going to write out 9 minus 4x. So I'm getting close to what I want. I want to have y by itself. So I've got one more thing I need to undo, and that is that I am multiplying that y by 7. So I need to undo that by dividing by 7, and I'm going to do that on both sides of the equation. And what I'm going to do here for this is, on the left-hand side, I'm dividing 7y by 7, right? There's just one term on that left-hand side. But on the right-hand side, I've got two terms. I've got the 9 and I've got the 4x. I need to divide both of those things by 7, okay? Because I need to divide each part of each side of the equation by that 7. And now what I'm going to do is just go through and simplify. So on the left, 7 divided by 7 cancels out. That's just 1, and 1y is the same as y. So I get y equals 9 can't be divided by 7 evenly, and I can't reduce that even as a fraction. So I'm just going to leave it, 9/7. It's not pretty, but it works just fine. I mean, there's nothing wrong with the number 9/7. Bring down the minus sign. And then same thing with the x. I've got 4x over 7. I can't really reduce 4/7. So I'm just going to leave it. And you can pull the x out of that fraction if you want and put it after, or you can leave it up in the numerator. Either way is totally okay. Okay. Now I have what I want. I have the y by itself. Got everything else over on the right-hand side of the equation. And again, the one other thing that I might do is just switch the order of that around. Actually, instead of the word or, just put a little arrow here. So I might switch that around and make this negative 4/7 x plus 9/7 and leave it that way. Okay. But the important thing is that I have solved for the variable I was supposed to solve for, and now this is an equation that I could put into a graphing calculator or a spreadsheet or whatever application I'm working with. All right. So on Moodle, there's one more video that is attached to the exercise set for these practice problems. There is a fairly short practice that you can do with these. And like I said, when we get into talking about two variable equations next week, we'll be looking at these same ideas as well. So we'll get some more practice with them. All right, hope this is helpful, and I will see you in class.